Imagine a world where sound, something so simple and familiar, could be transformed into pure energy. A world where you could hear a voice from anywhere, across any distance, just by converting sound into energy. It's a mind-bending idea, isn't it? But this is exactly what Albert Einstein hinted at, long before the technology to make it possible even existed. He said that the very fabric of our universe could allow such a thing, through his iconic equation, equals mc². But here's the kicker. When he first proposed ideas like this, no one believed him. They thought he was talking science fiction. Yet, as we'll see, this theory may have had its roots in something much bigger than anyone imagined. If you're ready to dive into the mind of one of history's greatest geniuses, hit that like button, subscribe, and share this video with anyone who needs to hear the secrets behind Einstein's groundbreaking theories. Trust me, you won't want to miss this. Albert Einstein wasn't just a brilliant physicist, he was a visionary who saw the world not as it was, but as it could be. Long before we were living in an era of technology that connects us in ways unimaginable, Einstein was already thinking about the universe in radically different terms. He was the man who redefined space, time, and energy. But what most people didn't know was that some of his ideas weren't just rooted in science, they were a glimpse into the future. A future where energy, sound, and light would behave in ways we couldn't even begin to fathom. When Einstein unveiled his theory of relativity, he didn't just change how we viewed the stars, he transformed the very way we understood the universe. He famously said, "Imagination is more important than knowledge," and it was this imagination that led him to the groundbreaking equation we now know as equals mc². The equation that would forever alter our understanding of energy, mass, and matter. But Einstein didn't just stop there. He was already thinking beyond the known boundaries of science, contemplating how the invisible forces around us, like sound, could one day be harnessed as energy. Imagine for a moment, what if sound wasn't just something we hear? What if it could be transformed into energy? Einstein's visionary mind wasn't confined by the limits of his time. He saw the possibility of a world where energy could be captured from the most mundane of things, like the very voices we hear every day. But when he first proposed these ideas, people were skeptical. After all, how could something so simple as sound, something that we take for granted, ever be more than just vibrations in the air? The world wasn't ready for Einstein's thoughts on sound and energy. But today, as we look back at his theories, we realize that maybe, just maybe, he was onto something. If there's one equation that's etched in the minds of millions, it's Einstein's iconic equals mc². But what exactly does it mean, and why does it matter when we're talking about the power of sound? Let's break it down. Equals mc² stands for energy equals mass times the speed of light squared. Now, that sounds like a mouthful, doesn't it? But in its simplest form, it says that energy and mass are interchangeable, two sides of the same coin. What we consider mass is really just concentrated energy in a solid form. This idea was revolutionary because it suggested that energy could not only be created but transformed, potentially even harnessed from sources we'd never thought to look at before. This equation wasn't just theoretical, it had real-world implications. Imagine for a moment that the very thing you thought of as static, mass, wasn't as rigid as it seemed. What if you could convert mass into energy? This idea laid the groundwork for nuclear energy, space exploration, and technologies we use every day. But where does sound fit into all this? Well, Einstein was looking at the universe as a giant energy exchange. He saw the potential in everything from light to sound waves to be part of that exchange. Sound, in its very essence, is energy. It's just energy in a different form, traveling through air and waves. And if mass can be converted into energy, why couldn't sound? This idea didn't gain much traction at the time, but Einstein's work opened doors that we're just beginning to understand. What if the very sounds we hear, like our voices, could be transformed into usable energy? A wild thought back then, but with equals mc², Einstein gave the world the key to start unlocking those possibilities. Sound is something we all experience every day. It's in the hum of a conversation, the crash of waves on the shore, or the beat of music that moves us. But have you ever stopped to think about what sound really is? It's energy, vibrations that travel through air, through solid objects, and even through space. So why isn't sound something we think about in the same way we think about other forms of energy? Einstein, with his unrelenting curiosity, recognized the potential of every form of energy, including sound. He saw the universe as an interconnected web of energy exchanges, where even the faintest whisper could be part of a larger cosmic system. But for most people, sound was just noise, a passing phenomenon that didn't have any deeper significance. It wasn't until we started to understand more about energy and matter that we realized sound, like light or heat, could be harnessed in powerful ways. Think about how sound waves travel. They are simply pressure variations in a medium, whether it's air, water, or even metal, that carry energy from one point to another. But what if you could take that energy and use it? What if the vibrations in your voice, the noise from machinery, or even the rumble of thunder could be captured and converted into usable power? Einstein's equation showed us that energy is all around us, and that energy, whether it's sound or light, is fundamentally the same at its core. While it sounds like science fiction, the very concept of converting sound into energy isn't as far-fetched as it once seemed. In fact, we're already starting to see technologies that harness sound in ways Einstein could only dream of. But let's take a step back. How exactly could sound be turned into usable energy? And what kind of impact could this have on our world? Let's pause for a second and ask ourselves, how could something as intangible as sound be turned into energy? The concept might seem abstract, even impossible, but what if we told you that this is something scientists have been working toward for years? To understand how sound can become energy, we need to break down what sound actually is. As we mentioned earlier, sound is nothing more than vibrations, waves that move through a medium like air or water. These waves are a form of kinetic energy, which means they involve movement. So, what if we could capture that movement and transform it into something more useful? This brings us to a technology known as piezoelectricity. Piezoelectric materials generate an electric charge when they are subjected to mechanical stress, essentially, when they're vibrated. This means that when sound waves, which are vibrations, hit a piezoelectric material, it can produce electrical energy. It's a simple yet powerful idea. Turn the kinetic energy of sound into electrical energy. Now, this doesn't mean we're going to plug our phones into a speaker anytime soon, but the principle is being used in real-world applications. For example, scientists have created small devices that capture the vibrations from everyday sounds, like the noise from traffic or industrial machinery, and convert them into energy that can power small electronics. It's not a huge breakthrough yet, but it's a step in the right direction. And let's not forget that this idea is still in its infancy. The technologies we have today are only scratching the surface of what could be possible if we truly harness the power of sound as energy. Imagine a future where your voice, the hum of the environment, or even the music playing from your speaker could power the devices around you. It sounds like a dream, but the groundwork laid by Einstein's theories could one day make it a reality. When Albert Einstein first began to propose ideas that seemed to stretch the limits of conventional science, he wasn't just met with skepticism, he was dismissed outright by many in the scientific community. His theories, while groundbreaking, were often so far ahead of their time that they seemed more like science fiction than science fact. And when he spoke of things like the possibility of sound transforming into usable energy, or how the universe's invisible forces could be harnessed, the idea seemed almost laughable. Think about it. Back then, no one had the technology to even remotely test such ideas. Sound was considered just noise, something we could hear, but nothing more. The concept that it could be turned into usable energy seemed absurd. It was easier for people to dismiss Einstein as a dreamer, someone lost in the stars rather than grounded in the practicalities of physics. Even though Einstein's work on relativity had changed the way we viewed space, time, and mass, his ideas about energy and sound remained speculative. The scientific community was slow to embrace his broader vision. In fact, it wasn't just the general public who couldn't understand his theories. Even some of his fellow physicists were reluctant to accept the implications of his work. The very notion that energy could be extracted from something as intangible as sound was dismissed as a wild thought. Sound, after all, wasn't considered a form of energy that could be manipulated. It was only when technology and science began to evolve, decades later, that the seeds Einstein planted started to sprout. But in his time, most of his peers wouldn't have believed that one day, his theories about the interchangeability of energy would lead to technologies that could convert everyday sounds into power. As science progressed, the world began to catch up with Einstein's far-reaching ideas. Technologies that seemed impossible during his lifetime started to materialize, proving that the boundaries he had imagined were not so far beyond reach. One of the most significant leaps came with the rise of technologies that allowed us to manipulate waves, whether they were light waves, sound waves, or electromagnetic waves. Take, for example, radio waves. When Einstein was talking about the transformation of energy, radio waves were already in use for communication, but they were still in their infancy. Today, radio waves are a cornerstone of global communication, from broadcasting to Wi-Fi. Radio waves, like sound, are essentially waves of energy that carry information. And as technologies like these grew more advanced, scientists began to see how these types of energy could be captured, manipulated, and harnessed for practical use. But it wasn't just radio waves. Advances in electronics, especially with the advent of piezoelectric devices, brought Einstein's ideas closer to reality. In the 20th century, the piezoelectric effect, where materials generate electricity from mechanical stress, was used in a wide range of applications, from sonar technology to powering small electronics. In other words, we started to learn how sound, in its purest form, could be used to generate energy. Today, we're seeing the beginning of a world where everyday sounds, like the hum of traffic or the vibrations in a busy city, could eventually be harvested and converted into energy. It's a direct link to Einstein's vision, and although we're still in the early stages, it's clear that his ideas were not just theoretical. They were a glimpse into the future, a future where energy could be drawn from the environment around us in ways we hadn't yet imagined. It's easy to look at Einstein's work today and see it as a grand success. After all, his theories are foundational to much of modern science. But the truth is, even Einstein himself faced immense challenges in getting the world to grasp his ideas. For much of his life, his revolutionary theories were met with resistance, not only from the general public but even from his peers. The nature of his work was so complex, so ahead of its time, that even the brightest minds struggled to understand its implications. One of the biggest hurdles was the sheer scale of his ideas. Einstein wasn't just redefining physics, he was reimagining how we perceive the universe. The notion that energy could be drawn from anything, be it light, sound, or matter, was not just difficult to prove, it was nearly impossible to conceptualize for scientists who were entrenched in more conventional ways of thinking. For decades, no one could test his ideas in a meaningful way, and many simply chalked them up to brilliant but untestable speculations. But the truth is, much of science, at its core, is about pushing past the limits of human understanding. It's about exploring what's possible even when we don't have the tools to prove it yet. Einstein's theories weren't just theories. They were invitations to think differently, to challenge the status quo. They asked us to imagine a world where energy is not a static resource but something dynamic, something that flows and transforms in ways we couldn't yet measure. It wasn't until later in the 20th century, after the advent of quantum mechanics, the exploration of nuclear energy, and advancements in electronics, that Einstein's predictions began to be tested, and many of them were proven true. But those who lived in his time couldn't see the future that he envisioned. In many ways, Einstein's ideas were constrained by the limits of the tools and knowledge available to him. While Einstein's theories were groundbreaking, it was the rise of quantum mechanics that truly began to link his ideas to the world of modern technology. Quantum mechanics, the branch of physics that deals with the behavior of the tiniest particles in the universe, seemed to confirm what Einstein had hinted at all along, that energy and matter are far more interconnected than we could have ever imagined. At the heart of quantum theory is the concept that particles behave as both waves and particles, and energy can be both a wave and a particle. This duality of energy, like sound, is something Einstein had hinted at in his theories, but it wasn't until quantum mechanics emerged that we began to fully understand the complexity of these interactions. Think of it like this. Einstein's equation equals mc², told us that mass and energy are interchangeable, one can be transformed into the other. But quantum mechanics added a deeper layer of understanding, revealing how this transformation happens on the smallest scale. Energy isn't just something we can harness from visible sources like light or heat. It exists in all things, even in the most unlikely places. Even sound, which we used to think of as just vibrations in the air, could potentially be seen as a form of energy that's in a constant state of flux. It's a bit like tapping into the hidden potential of the universe, a potential that Einstein's work laid the foundation for. Quantum mechanics provided the tools we needed to make sense of the invisible forces at work in the universe, forces that Einstein had always known were there but could not yet explain. The link between sound and energy, once considered a far-off dream, was suddenly within the realm of possibility. And as technology advanced, it became clear that Einstein's theories had not just predicted the future, they had paved the way for it. Now, imagine this. What if, in the near future, we could hear a voice from anywhere, just by transforming sound into usable energy? It might sound like science fiction, but the groundwork for this kind of technology has already been laid. Imagine a world where the vibrations of a person's voice, carried across the air, could be converted into energy to power your devices. It's a fascinating thought, one that brings Einstein's vision closer to reality. The possibility of turning sound into energy opens up some truly exciting doors. We already know that sound waves can travel through different mediums, air, water, and even solid materials. And as we discussed, technologies like piezoelectric devices are already making it possible to convert those vibrations into electrical energy. But what if we could take this concept a step further? What if entire cities, buzzing with noise, could be turned into vast energy sources? Every conversation, every car engine, every footstep could contribute to powering the world around us. This might sound far-fetched, but we're already seeing early applications of sound energy capture. For example, researchers are exploring the potential of harvesting energy from the hum of industrial machinery or the noise of busy streets. We've seen small-scale devices powered by sound, and while they may not yet be able to run your home, they show us that the potential is there. And that's just the beginning. The next step could be harnessing this energy on a larger scale. Imagine using sound waves to power everything from small gadgets to entire buildings. It's not just about hearing voices from afar. It's about listening to the world around us and finding ways to turn those sounds into something tangible, something powerful. Who knows? The very noise of life might one day be the energy that fuels our future. As we come to the end of this journey, it's clear that Albert Einstein's influence reaches far beyond the confines of his famous equation, E equals mc². His work didn't just change physics, it reshaped the way we view the universe itself. And while many of his ideas seemed outlandish at the time, today we see that they were the building blocks for some of the most incredible advancements in science and technology. Einstein wasn't just a physicist, he was a true visionary. His theories about the nature of energy, mass, and the relationship between the two laid the foundation for everything from nuclear power to space exploration. But perhaps his greatest gift to us wasn't just his equations or his research, it was his way of thinking. He taught us to question everything, to imagine what could be, not just what is. He encouraged us to look at the world differently, to see potential in things that seemed impossible. And though Einstein may not have lived to see all of his ideas come to fruition, his legacy is alive and well in the world we live in today. Technologies that once seemed like science fiction, sound converted into energy, the manipulation of energy from unexpected sources, are now becoming a reality. In many ways, the future that Einstein imagined is slowly unfolding before our eyes. As we continue to explore the mysteries of the universe, Einstein's vision still guides us. His work was not just about understanding the laws of nature, it was about unlocking the possibilities that lay hidden within those laws. Today, we are closer than ever to realizing the incredible power of sound, energy, and the universe's interconnected forces. And as we do, we honor the legacy of a genius who saw not just the world as it was, but as it could one day be.